discussing the organic chemical technology course. Today we will be discussing module 8 of the this course, and where we will be discussing about the polymer industry, because already we have discussed about the various petrochemicals, major feedstock, and the your intermediate, some of the intermediate which are finding use in the manufacture of large number of the product. So, in the polymer we are having 8 lectures. Lecture 1 will be on the introduction to the polymer. What are the various type of the polymers we are manufacturing, what are the classification of the polymers, and importance of polymer. As you know that in daily life everything that we are using in some other form, that and that is from we are using that polymeric compounds. So, today this module 8 is on the polymer, elastomer and synthetic fiber. So, that will be the coverage will be the 8 lectures, because first few lectures that will be on the polymer part, then elastomer, and then the synthetic fiber. In the synthetic fiber we will be also discussing the viscose yarn, which is one of the important sector in case of the synthetic fiber. Today we will be discussing in general about the polymers, elastomers and synthetic fiber. If you see the here the product which you are getting from the polymer and their application. So, wide application of the polymeric compounds are there, whether in the form of the plastic, in the form of the elastomer, or in the form of the synthetic fiber. So, this is the, as I told you, this is the only just introduction about the polymer, elastomer and the synthetic fiber, and about the polymerization in general. So, this will be the coverage of the lecture: introduction, various types of the polymers and their application, classification of the polymers, plastic industry in India, various thermoset and thermoplastic resins, elastomers, man-made fiber, raw material, and overview of the Indian man-made fiber textile industry. As I told you, the polymers, they are playing very important role in all sectors. So, polymer were actually accidentally synthesized. However, as more and more applications were later discovered, so polymers have entered into all fields of application, and in volume of around 205 million tons per annum, including standard polymers, engineering resins, elastomers, deromers, fibers, textile, dispersions, and so on. So, you see the in case of the engineering plastic, and one of the very important sector you saw the automobile sector, where the, or even the in case of the electronics and communication, this polymer that has played important role. So, this is, if you see the various product profile of polymers, we are using the building construction, packaging, electric and the electronics, agriculture, medicinal, automotive. So, no area is left where in some or other form we are not using. Here in case of the building and construction, now the various actually the starting from the window, door and the other application, we are using the plastic pipes are now being used extensively in the which has replaced the conventional pipelines for the water supply. Even in agriculture also, packaging, you are seeing the revolution, it has replaced the conventional glass which were being used for the packaging, and the carry bags which was made of the paper. Similarly, electronics and so innovation, energy efficient and miniaturization, that is the one of the area that the most of the part, whether it may be the computer, laptop or the any electronic devices, we are using the polymeric compound in some or other form. Similarly, the agriculture, food and water supply, now the poly bags, we are having big bags which used to be jute bags, now it is the polymer, they made a, we are using the polypropylene bags, and for the storing cement and other raw materials, also the sugar and the fertilizer, this all being now packed in the polymeric bag. Similarly, the medicinal where the polypropylene that is finding, and other polymers are also finding use, automatic, and now you see the weight of the lightweight vehicles, high speed vehicles, and they have a major portion of the, it may be in the form of the polymer, polypropylene, bumper and other thing that is made of polypropylene, and tire, that is also synthetic rubber that we are using, tire cord lining, synthetic fiber. So these are the broad application, and if you see how the polymer that is playing important role in our daily life. These are the other some of the major application. Even you see the badminton racket, or the in the sports shoe, polycarbonate on the toes of the shoe that we are using, high impact strength is there. Similarly, now the conventional their football, that is also there we are using now the new breed of the material that we are using, the packaging, and then the containers, and then you are seeing this is the in automobile sector, chairs, plastic chairs that is available in the market. So this is the broad how the polymer consumer application of the polymers are there. Global demand for polymers is estimated to increase at 5% per annum. Here actually this is the only, this figure is the it is not for the synthetic fiber or the elastomer. So plastic industry in India consumption about 4.8 million tons per annum. Over 96% is accounted for commodity plastic. Per capita consumption 4.8 kg against the world average of 20 kg. So our per capita consumption, but you see they always the per capita consumption is not exact figure which give, because our population is more, so the per capita consumption that is less always in the wherever the population is. Projected demand that is around 8.5 million tons in 2010-11. Raw material prices are influenced by international demand and supply of the crude oil, because the basic raw material which we are using for making of the polymer, it may be the your ethylene, propylene, or it may be the xylene, whatever the or styrene from the ethyl benzene. This is influenced by the international demand and supply of the crude oil, because the always we are interested for the export of the material, but the price will have to meet the international market, the international price, international quality if you want to import. So these are the some of the factors which are influencing the raw material prices and at the same time growth of the polymer industry. Amongst the, because the polyolefins, various forms of the polyethylene, low density polyethylene, linear low density or high density polythenes or polypropylene are by far the largest group of the thermoplastic polymers which we are using. Polypropylene resins among with the polyester resins are one of the fastest growing categories of the commodity thermoplastic resin in the world, because we are having the two types of the plastic, one is the thermoplastic and other is the thermoset resins. This is about the global picture of the polymers. The United States and China now represent more than 15 to 22% of the world propylene consumption, because the propylene that is the, and this was the reason why the high propylene is in high demand, and the refineries they are operating, or even the cracker plant they are operating more in the propylene mode. So polyvinyl chloride is the second largest commodity thermoplastic in the world after the polyethylene, because the PVC earlier many of the application which has been replaced with the other polymers because of the some problem in case of environmental problem, because the toxicity of the vinyl chloride and other problems are there. So but still the PVC, even the growth of the petrochemical industry in this Middle East and other part, that was with the production of the PVC, and where the large amount of the chlorine that was being used, and so that was also the reason for the development of the caustic chlorine industry. The global consumption of polyethylene in 2009 was approximately 64 million tons with capacity utilization of 80%. In terms of volume, SDP, the high density polyethylene, is the third largest commodity plastic material in the world after PVC and polypropylene. The 2008 world consumption, the SDP represented global per capita consumption of 4.5 kilogram. This is the, you see the word polymer demand in 2010, and LLDP, polypropylene and the PVC. These are the two major. But if you combine this LLDP, LDP, SDP, so that is also appreciable. Other type of the polystyrene, ABS plastic, or the PVC, PET resins, because now the PET resins and the polyester that was only confined to the synthetic fiber manufacture, but now the PET resin with the same raw material with some modification in the process, now we are making the PT resin, which has replaced most of the glasswares which are being used for the packaging of mineral oil and other thing. So the PET resin that is coming in a big way, and already Reliance they are having the two plants, another plants also they are going to have their new units of Gandhar. Let us discuss something about the fiber industry, because synthetic fiber, elastomer, these are all coming in one form of the polymer, because here the by polymerization of the monomer, that we are a monomer, the comonomer, whatever it may be, we are making the polymer, and so the elastomers and your this synthetic fiber, they are also the polymer. So demand of the textile good across all markets fell dramatically, and global fiber production dropped from 11 to a low of 61,000 metric tons, down from a high 6,896 in 2000. So that is some figure about the synthetic fiber. But synthetic fiber for the first time in 2000, China produced over half, 51% of volume of the natural and man-made fibers that were produced globally. So this is the how the changes that has taken place in case of the synthetic fiber, because China in the polymer industry, in other development that has come in a big way, and you see the now the whole market that has been captured by the Chinese. So annual growth during 2009 to 2014 is expected to average 2% in North America, 2% in the Western Europe, and 0.5% in the Japan. These are the, because we are talking about in general about the polymers. So what are the methods of polymerization? Because these are the some of the methods which are being used in all the three category of the polymer, that is the plastic, then the synthetic fiber, the elastomer. Bulk polymerization, solution polymerization, emulsion polymerization, and the suspension polymerization. So these are the four major type of the polymerization process that we are using, and depending the method used is dependent upon the economic consideration, end use of the polymer. Temperature control is very important factor in the all the polymerization reaction in selection of the polymerization process. Catalyst control and purity of the product are also important, and so this is the reason of continuous development that has been there in the development of the catalyst which we are using in case of the various polymerization reactions. Bulk polymerization, here pure liquid or gaseous monomer is subjected to polymerization condition. Exothermic heat removal is main problem. This is accomplished by continuous and fairly complicated heat control system. The product produced is essentially free from impurities. It is used for large scale production of the molding powders. Monomers are, in case of the solution polymerization, monomers are dissolved in suitable solvents and polymerization is carried out in solution. Heat removal is relatively easier. Slow reaction rate gives low average molecular weight product. Trace of solvent remains in the product. This is the about the solution formation. These are the various polymerization reaction that is taking place. Before going to the polymerization reaction, let us discuss other method of the polymerization, also the emulsion formation. The liquid or liquefied monomers are brought into emulsified state and reaction proceed very rapidly. The average molecular weight of the polymer is higher than the bulk or the solution polymerization. The polymer produced by emulsion formation may not be suitable for optical clarity and excellent electrical insulation. Suspension polymerization, as the name itself suggests, in this type of the polymerization, the monomer is polymerized while it is kept in suspension. It is suspended in absence of emulsifier in a non-solvent media. By adequate agitation, the liquid monomer is dispersed into the globules of varying size, and after the polymerization is finished, the polymer has the form of regularly shaped space. So this was about the various type of the polymerization that we are performing in industry, and this is the just what are the various polymerization reaction. As you know, then we are having the two type of the polymerization reaction, that is the addition, chain polymerization, condensation, or the step polymerization. Condensation always some release of the additional molecules are there, as in case of the some of the you see the it may be water or then it may be methanol in one process. So depending upon that, the some release of the additional, then the main product is there. So additional, that may be the free cationic, anionic, group transfer polymerization. In case of the condensation, homopolymerization, copolymerization, or polymerization. So these are the different type of the polymerization reaction that is taking place. So polymer, plastics, extruded molded films, foam. As I told you, the polymer is the general name we are using for all the whether it is the plastic or the synthetic fiber, because the plastic is a polymer, but after addition of the various actually other materials that they are, when we are it is going for the molding, so we call it the plastic. So plastics, extruded molded films, foam, synthetic fiber, elastomer, coatings and adhesive. There also we are using the polymeric compound, polyvinyl chloride, like that. So polyvinyl acetate. So these are all the coming in the case of the coating and adhesive. So this is in a various types of the polymers and their application. Polymers, plastic, extruded molded foam, synthetic fiber, elastomer, coatings. So these are the various types of polyethylene, polyvinyl chloride, polystyrene, and that is the styrene monomers, polypropylene, acrylonitrile, butadiene, styrene, cellulose estate, phenol resins, melamine, formaldehyde resins. These are these three are the thermoset resins. So the various type of the which are using we are using as the plastic. Then the foam, polyurethane, polystyrene, expandable polystyrene or the polyethylene. So the polyamides, nylons, synthetic fiber, the polyamides mean nylon 6, nylon 67, polyester, acrylic fiber, polypropylene fibers, cellulose estate, viscose yarn. These are all coming in case of synthetic fiber. Elastomer, we are having the various type of the elastomers, styrene, butadiene, nitrile level, polybutadiene, polyisoprene. So all these are the various type of the. Then the coatings, as I told, the epoxy, urethane, then the unsaturated polymers, polyvinyl acetate, acrylic, formaldehyde resins, silicones. So these are the various type of the in the resin that we are using. Characteristic of the polymer. Some of the important characteristics of the polymer are its molecular weight, because the molecular weight and molecular distribution, that is very important in the which will have the impact on the quality of the product. Thermal transition temperature, glass transition temperature, melting point temperature, its physical state, which crystalline, semi-crystalline, are the amorphous, interchain, interaction and structure. These are some of the important property of a polymer. As I told you, we are having the two types of the, in case of the molecular weight, that is very important. So we are having the two types of the molecular weight of the polymer affects the quality of the product. Two types of the molecular weight have been used in the characterization of the polymer, that the number average molecular weight and the weight average molecular weight, which are calculated from mole fraction distribution and the weight fraction distribution, different size molecules respectively. Polymer consisting of the similar repeating unit is called, because you see we are having the copolymers also, where we are using some co-monomer, and so they just like in case of the polyethylene we are also adding butene 1. So in case of the modified acrylic fiber, we are using the vinylene also there, or the vinyl chloride also. So the various combinations are there. So the polymer consisting of the similar repeating units is called homopolymer. With the polymer consisting of 2 or 3 monomers is called the copolymer. So this is the another classification you can say for the polymer. Copolymer may be random, alternating block, or the graft copolymers. Monomers from 5 basic molecular structures, because you see the, now we are talking about the linear. So linear, cross-link, branch, graft, or the interpenetrating. The various combination that may be there in case of the polymeric structure. This is the linear branch. Actually it is not visible, but you can see the branch and the cross-link, interpenetrating, graft. So these are the various type of the polymers that we are getting. Now let us see the production in India, status of the polymer, synthetic fiber and the elastomer industry in India. Synthetic fiber, elastomer and the performance plastic. Polymer is the highest, then the synthetic fiber, elastomer, and the performance plastic means that the specialty plastic, which are ABS, where this combination of acrylonitrile, butadiene, styrene, nylon 66, nylon 6, polymethyl methacrylate, styrene, acrylonitrile, various combinations. So these are this is the figure of the production during the 2009 and 10. These are some of the new polymer projects are being planned, or they are at the erection stage. That is Opal by ONGC, Dahej. They are going to have a big petrochemical complex. It is just here near the Gandhar unit, where the Reliance they are having their petrochemical, and that is also going to be they are going to add some more units there. SPS Mittal, Panipat, RIL Jamnagar. That is because they are having the refinery, a big refinery, largest refinery in India, and now they are going to have the petrochemical complex also, the cracker plant and other related product they will be manufacturing at Jam. GAIL Assam, that is in collaboration, Brahmaputra cracker plant is coming, a very big cracker plant, first time that is coming in Assam, and where they will be producing large number of the polymer there. The GAIL Pata, that is already they are another unit is coming. MRPL Mangalore, they have also gone for the cracking plant, and so the other projects are just like you take case of the Panipat refinery. They are going to have now the SBR unit, styrene butadiene rubber. Earlier they started making terephthalic acid, which is the basic raw material for the polyester. Polymer demand in India is expected to grow at 13 to 14% per annum and will account for 9% of the global polymer demand by 2050. 15. The total polymer demand in India by 2015 is estimated to be around 22 million metric tons. India 4%, 9%, and rest of the world 96, 90. Still our demand is less, per capita consumption figure is less than if you compare with the rest of the world or the world average figure. This is the broad classification of the polymer, which was telling different type of the based on the technology, based on the polymerization model, and then the chemical based on the chemical constituents, based on the your structure. So different actually the classification is there. Already I discussed some of the different type of the based on the reaction, based on the your because we are having the different type of the polymerization based on the catalyst also. We are having the Ziegler-Natta catalyst, we are having the metals in catalyst. So different catalysts also, as I told you, that there has been continuous development in the, so that we call the metals in catalyst. In case of the olefins, that is the new development that has taken place. So this is the alternative random, the block graft structure which I discussed. So depending upon that, the classification of the polymer that has been done. Now let us go. We are, as I told you, we are having the two grade classification, major classification in case of the plastic, that is the thermoplastics and the thermoset plastic. So thermoplastic are organic chain polymers that usually become soft when heated and can be molded under pressure. Thermoplastic resins are linear or branching polymers with little or no cross linking. So this is the, and one actually major plastic we are polymers which are using, that is the thermoplastic, whether it is polyethylene, polypropylene, PVC, and some of the synthetic fiber also, they are coming in the category of the thermoplastic. That will be this. I will show the list of the various thermoplastic and thermoset resins. Thermoset resins are a network of the long chain molecules that are cross-linked, which gives the polymer a three-dimensional infusible structure. They polymerize irreversibly under heat or pressure to form hard rigid mass. Various thermoset resins. So these are the three very important thermoset resins, that is the phenol, phenol formaldehyde, urea formaldehyde, melamine formaldehyde, polyurethane, alkyd resin, epoxy resin. So these are all coming in category of the thermoset resin. This is the major plastic processing method, because whatever the plastic we are getting or the polymer we are getting, it has to be further processed in the different shape. So depending upon the process we are having either the blow molding, compression molding, injection molding, extrusion molding, transfer molding, casting, encapsulation, coating, lamination, fabrication and decoration. So these are the different type of the processes, finishing processes from the polymer to the finished product that we are doing. Suppose if you want to make bottle, or if you want to make a chair of the plastic. So depending upon the method, different type of the method, we can go for the choice of the different processing schemes. Polymerization type, already I discussed that we are having the addition polymerization, just like polyethylene, polypropylene. Here we are having the addition polymerization. In case of the condensation polymerization, PET, nylon 66, mechanism of the formation free radical, that is the LDP, PVC, coordination, polypropylene, PBr, ionic, cationic, anionic, polyacrylonitrile. So these are the different type of the polymerization that is taking. So this is the how the major thermoplastic, which I was telling, a major category of the plastics are in the polyethylene, that may be different forms of the polyethylenes are there, polypropylene, polyvinyl chloride, and then the polyvinyl acetate, polystyrene, polymethyl acrylate. These are all coming in category of this thermoplastic resin. Again, polyhexamethylene, diamine, polycaprolactam, polyethylene, terephthalate, PET, which I was telling, that is also coming in the category. So large number of the plastics, they are polybutyl terephthalate. This is also another development that has taken place because of this stronger better property than the PET. Polycarbonates, as you see, now the most of the optical glasses, or even in case of the CD and other material, that you are using the polycarbonates and other specialized, lightweight and very high strength polycarbonate. Even in case of the sports shoe also, we are using the polycarbonate. Polyacetols. Then the various type of the thermoset resins are polyurethane, alkyd resin, epoxy resins, and as I told you, the phenol formaldehyde, urea formaldehyde, and the melamine formaldehyde. These are the other very important grade of the polymers which are finding application. One of the, because the phenol formaldehyde, that came in the name of the bakelite earlier, and the major application that was in the electrical applications, especially the switches and the materials that was made, that is made of the phenol formaldehyde resin. So that was the name, the starting the bakelite name was given. Melamine formaldehyde, that is actually one of the very important polymer, and that actually during the 70s, 80s, lot of the revolution that take place in case of the kitchenwares, and the melamine almost they completely replaced the conventional stainless steel utensil in the kitchen. So that was the development in case of the melamine formaldehyde. Now let us come to the elastomer. Rubber can be, because when we are talking about the elastomer, means the rubber, even the clauses are now, or the stretchable jeans and other thing that is there, but in case of the rubber, can be broadly classified as natural rubber and synthetic rubber. Natural rubber from the natural source. Natural rubber is a product of tree, heavy breathlessness, while synthetic rubber is elastomer derived from the petrochemical feedstock. And as I discussed earlier also while discussing the petrochemical, starting from the ethylene, propylene, and then the styrene, and all those are playing very important role, or isoprene, or it may be the isobutylene, butadiene. These are playing very important role in manufacture of the polymer, elastomers, as well as synthetic fiber. Synthetic rubber is playing important role in meeting the gap between demand and supply of the natural rubber, because many of the countries, they are not producing natural rubber. So from where? So that is they are meeting their demand through the synthetic rubber. So the natural rubber, the synthetic rubber is playing important role in meeting the gap between the demand and supply of the natural rubber. At the same time, various synthetic rubber have been able to overcome some of the deficiency of the natural rubber. The share of the synthetic rubber in India is only 30%, whereas the global average is 55%, because India is also one of the natural rubber producing country. These are the various type of the general, because we are having the general purpose elastomer, special purpose elastomer. So this is the styrene butadiene rubber, styrene butadiene emulsion, polybutadiene, polyisoprene, ethylene propylene, and the ethylene propylene diene, butyl rubber, ethylene vinyl ethyl vinyl acetate. Then the special purpose elastomer, because as I told you, we are getting in some cases the better property than natural rubber. So the polychloropene, styrene, isoprene rubber, acrylonitrile, butadiene rubber, because NBR, that was the because during the World War the development of this acrylonite butadiene rubber, that was there because it having good resistance to our oil. So another type of we are having silicone rubbers, acrylic rubber, then the polystyrene, polyisobutylene, polyether urethane elastomer, epichlorohydrin, polydialkyl silaction, vinyl pyridine butadiene. So these are the various type of the special purpose elastomer. This is the status of the production of the synthetic rubber in India, and you see here the styrene butadiene and the polybutadiene rubber. They are the major actually the player where they, because in some of the petrochemicals like Reliance and the your Haldia petrochemical, they are having the naphtha cracker. So lot of the butadiene they are getting from the naphtha cracker, and so that butadiene that is going that is polymerized for getting the polybutadiene. Similarly, styrene butadiene rubber, that was the first rubber, you can say synthetic rubber, large volume synthetic rubber, you can say for the SBR, and the new unit which you are going to have in India, that is by the SBR plant by Panipat refinery, where they will be using the ethylene from their process, FCC gases, and then the styrene also from the aromatic complex through the ethyl benzene. So that is the some two type major elastomers there. Then the nitrile rubber, ethyl propylene dimer. So this is the installed capacity and this is the production figure. Now let us come to the synthetic fiber industry, because synthetic fiber industry that has been playing important role, not only because it is oven and non-oven, both the areas are there where the synthetic fiber they are find wide application. One of the major applications start from the textile, that was in the tire cord industry, where the synthetic fiber they have played very important role in the tire lining, because as such you cannot use the elastomer. So although the history of the textile market using natural fiber is from the ancient time, however 18th and 19th century witnessed an era of industrial revolution resulting in tremendous upsurge in the fiber production, and this was only possible with the coming of the large number of the petrochemicals. So synthetic fiber are the indirect consequence of the spectacular growth in the petrochemical industry, because the raw material which is available, whether it may be the cyclohexane, which is we are manufacturing from the benzene, or the production of the nylon 6, where we are using the cyclohexane as raw material, or the nylon 66, adipic hexamethane diamine, or it may be the your polyester. In all the cases, whatever the development or the revolution that we are seeing, that is because of the coming of the number of the petrochemical complexes and the availability of the raw material. Although the synthetic fiber industry in India, that was started in 1950 by using the imported synthetic fiber, the indigenous production however started only in 1960, and real growth has been witnessed only in the last 10-15 years, with the large scale units coming up in the country. And Reliance one has been the important, actually the petrochemical complex which is playing very important role through this making of the terephthalic acid, purified terephthalic acid. Even their first class Patalganga, that was the first unit which was started with the PTA, because other units which were started, whether it was the bamboo dyeing or it may be the BRPL, they were all based on the DMT, and many of the units at that time came based on the DMT, but now all the DMT plant that has been closed. That will be, I will be discussing while discussing the synthetic fiber in more detail, how the TP terephthalic acid that has played important role, and now even the synthetic fiber industry, what is the role. So that will be discussed while discussing in the chapter of the polyester. So as I told you, the real growth that has been only during the last 15 years, you can say, with the coming of the number of, or we can say the even after the 70s, some of the petrochemical like the IPCL, now Reliance, they started making DMT similar to the BRPL, but real growth was during the last 80s and 90s, you can say. First made fiber, natural occurring polymers from cellulose and protein, that was the viscose rayon, first manufactured in 1986 in England, first two synthetic in 1935, nylon by DuPont. Nylon was followed by acrylic and modified acrylic fiber based on the acrylonitrile in 1950, polyester fiber in India 1953, viscose rayon in India started in 1950, because in case of the viscose rayon we are using the cellulosic pulp. Cellulosic material means the pulp which you are getting a good quality of the pulp which is high cellulose content, that we are using in case of the viscose rayon or the acetate rayon, and 1950, because acetate rayon is just like this silk. So one of the unit now it is closed, that was the Sirpur Kagasnagar, where we are making the acetate rayon, and the number of the viscose rayon plant are in India, and Grasim industry, they are the one of the major player, major manufacturer of the viscose rayon. Raw materials for man-made fiber. As I told you, the various raw material which is available from the petrochemical, they have played very important role in the growth of the synthetic fiber industry. Not only synthetic fiber industry, it is all the polymers, whether it is the polyethylene or the polypropylene, or it may be the elastomer. In all the cases, the synthetic the petrochemical industry, they have played very. So these are the some of the broad, actually the raw material for the petrochemical industry, means the where we are making the final product, ethylene, propylene, that is in case of the, it is not only man-made fiber but also in case of the other polymer compound. So ethylene, propylene, butadiene, isoprene, styrene, vinyl chloride, vinyl esters, vinyl ethers, chloropene, acrylic and methacrylic esters, vinyl ethers, chloropene, adipic acid, hexamethyldiamine, caprolactam, terephthalic acid, ethylene glycol, because one of the major, this terephthalic polyester making is one of the major consumer of the ethylene glycol which you are making, and this is the reason most of the petrochemical complexes, they are having both ethylene oxide and ethylene glycol, the MEG, monoethylene glycol plant, and the formaldehyde. So this is the status of the consumption of the non-oven, because as I told you, the oven and non-oven both the we are using the so this is the fiber. So man-made fibers, polyester, polyamides, acrylic fiber, polypropylene fibers, viscose and other synthetic fiber. So this is the figure if we compare from 2006 to 2007. These are the some of the your non-oven industry, where you see the polyester, now it is being in huge amount, and other the propylene fiber also. This is the actually the broad classification as we discussed in case of the plastic or the polymer. So the fiber that may be based on the natural fiber, that was the earlier cotton, wool or the silk. These were the natural fiber, and the ancient time we have been using the natural fiber. Synthetic fiber or the man-made fiber which is called, that may be the two types, that may be the based on the natural raw material or based on the petrochemical. Other type of the man-made means the refractory and the related fiberglass, carbon glass, that will find application of the fiberglass making some. I saw one photograph, that was a lady in Italy, she was wearing a cloth made of the fiberglass. So this is how the metal fibers, warriors earlier, they used to have the coverage with the metal oven fibers. So metallic oxide, these were the also coming in the category of the synthetic fiber. So another classification, the true synthetic fiber or synthetic polymers, where you are having the polyamides, polyesters, acrylic fiber, vinyl and vinylidene fibers, Teflon, that is also because high corrosion resistance, and you can use at a high temperature, because here in case of the other synthetic fiber, melting point that is around 240, 230, but in case of the Teflon you can go for a high temperature, high resistance for corrosion is there. So Teflon fiber for this specialized application, that are also being used. Polyethylene also that is coming, and that we are using raw materials, various raw materials which are there, that is the benzene, cyclohexane from the benzene, that we are using for caprolactam, adipic acid, ethylene glycol, for the terephthalic acid, DMT that we are using, paraxylene also for these, then the acrylonitrile vinyl chloride in case of the acrylic fiber. Semi-synthetic fiber, there is again a number of the semi-synthetic fiber which is made from the cellulosic material. So the viscose rayon, that is one of the major industry, because now in the textile, along with the polyester, viscose being playing a very important role as a substitute of the cotton, because the viscose is more comfortable, especially for the high temperature region, just like the India we are having the because they are having the better moisture absorbency than the your polyester. So now the blend is to give the more comfort. We are having a blend of polyester and the viscose. So normally 70-30% of the combination. You see the any cloth here, that is having the polyester and the viscose combination. Pyroxylene rayon, and then the other casein fibers, then the soybean fiber, these are all the small alginate fiber, these are the small amount of the portion, but the major portion is the viscose and the acetate rayon, and acetate rayon also we are having the copramine acetate rayon. So these are the where we are using the high cellulose, alpha cellulose content cellulosic material, and so that the process again we will be discussing in detail about the semi-synthetic fiber, especially the viscose rayon and acetate rayon, by discussing the viscose rayon chapter. That will be the last lecture of this module, where we will be discussing about the manufacture, and they also will be discussing separately the manufacture of these synthetic fiber, true synthetic fiber, polyamides, acrylic fiber or the polyester. These are the some of the terms normally we are using in case of the synthetic fiber industry. Denier is defined as the weight in grams of the length of 9,000 meter, text and millitext, tenacity, elongation at back. So these are the terms normally we are using in case of, just like in case of the paper we use the gram weight. So similarly we are using these terms. Again I will be discussing this point in detail while going with synthetic fiber, But you see in case of this, why these properties are very important. One is the twisting we are doing in case of synthetic fiber. That is very important to give the more and more strength. Overview of the Indian made industry, second largest producer of the cellulosic fiber, and as I told you the 1950, and the builders, they have been an important player in the manufacture of the cellulosic fiber. Fifth largest producer of the synthetic fiber yarns. Production of this synthetic fiber nearly 10 lakh metric ton, production of synthetic yarn about 15 lakh. Because we are having if you see the whole petrochemical industry, we are having one large integrated, then where we are making the intermediate, and then that intermediate that is going to the other downstream processing of the petrochemical, where you can process either because in the polyethylene chips that may be available, fiber in case of it may be stable fibers, or yarn that may be available, and the final finishing of these staples and fibers that is being done in other units. So current all fiber demand is around 80 lakh tons, cotton 43 lakhs, and polyester around 30 lakh. All fiber demand to grow nearly 130 lakhs metric ton by 2020. Polyester fiber has grown at around 10% CAGR in the last decade and is likely to sustain similar growth. Indian textile growth drivers, higher disposable income and changing lifestyle, increasing fashion awareness, even entire new emerging segment of non-apparel application, increasing urban households and working women population, rapid spread of the organized retail sector, a rise in exports to traditional and new markets, favorable government policy. So these are the major growth drivers, and you see the textile industry that has played a very important role in development of the this polyester synthetic fiber. They have played very important role in the development of the textile industry, and now you will find all the places, most of the textile which were totally dependent upon the cotton, now they are having they are making the polyester fiber, they are making the polyester yarn, they are making the polyester cloth also. But one of the problem, you see why the nylons and the polyester, although they are cheaper than the cotton, still they are not being used, and viscose combination is there, it is not the polyester and nylon, because the polyesters, they are not comfortable as we compare to the viscose or the cotton. So the combination is always, even acrylic fiber, you see the woolen industry or the hosiery industry, this is all coming of the nylons. Earlier even the nylons, sweaters and other thing, that was actually they replaced the conventional woolen fiber. But after coming of the acrylic fiber, the real growth in case of the your woolen industry, that was because now we are using the blanket in the market, you are finding all the maize of the acrylic fiber. Even in case of the carpet industry, in case of the this curtain industry, lot of the development and the cost that has been reduced. Earlier the people used to have the woolen fiber for the carpet, but now it has been replaced with the acrylic fiber. So this was in general about the overview of the polymer industry, the various polymers, and the next few lectures will be discussing in detail about the individual polymers. So first the second lecture, that will be on the polyolefins and the polystyrene, because these are the three major polymers which are manufacturing, and the next lecture will be third lecture, that will cover PVC and some other plastic. So this was all about the your general polymer industry.